Good afternoon. Today we are going to talk about when a function is increasing and decreasing. This is a fundamental concept in calculus and helps us understand the behavior of functions. But first, what do we mean by increasing and decreasing? So, increasing. On an interval if, for any 2 points x1 and x2 in that interval, if x1 is less than x2, then f of x1 is less than f of x2. Decreasing. Decreasing on an interval if any 2 points x1 and x2 are on that interval. If x1 is less than x2, then f of x1 is greater than f of x2. So the most common method to find increasing and decreasing intervals involves the first derivative of the function. And so here are a couple steps to find the derivative and what we do with that after. And so first, step 1, to find the derivative f prime of x. This derivative represents the rate of change of a function. And so we now move to step 2. Identify the critical points. These are points where f prime of x is 0 or where f of x is undefined. F prime of x is undefined. Critical points are crucial because they are potential locations where the function may change from increasing to decreasing or vice versa. Step 3. Create a number line to analyze the sign of f prime of x in the intervals created by the critical points. And so once we have found the critical points, we set them up on a number line. And after that, we choose our test points. And so these are the steps that we take when we are using those test points. Step 1, choose the test points from each interval. These are values of x that lie in the intervals defined by the critical point. So for example, it may be one of our critical points, as we'll see later in the example, is 0. And so we would use 1 or -1 as our test points because they fall in the intervals defined by the critical points. Step 2, we evaluate the first derivative, f prime of x, at the test points. And so we have now gone over all of our steps to find if a function is increasing or decreasing. And so here is a summary of the steps. First, we find the derivative of the original equation. Then we set that derivative equal to 0 to find our critical points. Then we determine the intervals based on the critical points. Next, we choose test points and evaluate f prime of x on the intervals. And lastly, we conclude which intervals are increasing or decreasing based on the sign of f prime of x. So let's move into a little bit of an example now. So consider the function x cubed minus 3x squared plus 4. And so we are going to apply the steps that we just went over to this equation. So first we find the derivative. That would be 3x squared minus 6. Now, like we set up here, to find our critical points, we set our derivative equal to 0. As you can see, I've done that there on step 2, and this gets us the critical points of x equals 0 and x equals 2. Next, we identify the intervals, the critical points x equals 0 and x equals 2, split the number line into the intervals. I've done that here, and so our critical points are highlighted in the blue pen. And so as you can see, if you read number 4, we choose test points. So let's use x equals -1, x equals 1, and x equals 3. And those are indicated by the red pen. And so lastly, we evaluate the derivative. And so what we do is we take our test points. So for our first one is x equals -1. And we take our test points and we plug that back into the derivative equation. So as you can see, I've done that here. And so we have f prime of -1, equals 3 times negative 1 squared minus 6 times negative 1. This equals 3 plus 6, and that equals 9. And so we know that 9 is greater than 0, indicating that this function is increasing from negative infinity to our critical point 0. Next, we're going to take our next test point 1. So we plug it in. F prime times 1 equals 3 times 1 squared minus 6 times 1. This equals 3 minus 6, That equals negative 3. And we know that 0 is greater than negative 3. So we know that this value is decreasing from 0 to 2. And lastly, we take our last test point, and that is 3. We plug it into the original derivative equation. Not the original equation, but the derivative equation. So, if we do f prime times 3, this would equal 3 times 3 squared minus 6 times 3. This equals 27 minus 18, and ultimately that equals 9. We know that 9 is greater than 0, so that indicates that this value is increasing from 2 to infinity. So, remember that when we are using our critical values and our test points, we plug our test points into the derivative equation. And so, to conclude what we have talked about today, we have determined that from the points negative infinity, 0, and 2 infinity, we have found out that they are increasing values because when we plugged in our test points, they were greater than 0. And we have determined that the value 0, 2 is a decreasing value because negative 3 is less than 0. And so, understanding how to find intervals of increasing and decreasing values allows us to better analyze and interpret the behavior of functions. Thank you for your attention, and I hope this helps clarify the concept of increasing and decreasing intervals. Thank you.